Hello friends, good morning. Welcome back to our channel ALP Talks. Today we are going to discuss a few things about harmonics. What are harmonics? What is their impact? From where they are getting generated? What are different types of harmonics? How we can reduce it or mitigate it? So, some general discussion we are going to make today. Yeah, this is actually very big discussion, but in like a series we are going to discuss part 1, part 2, something like that, so it is helpful to everyone. Yeah, so let's before going to the complete harmonics topic, let's discuss or brush up some few topics, voltage, current, waveforms, and some generation and all. So let's see it. So everyone is familiar that DC voltage, it will be constant irrespective of time. The magnitude is fixed. Say for example, say you have source here, so you have load here. So whatever the source is generating, the load is consuming. The voltage is a fixed value. So in AC it is not like that. For every time it changes magnitude. Yeah, for example, if you see here it is 0 magnitude. If you see here it is for example, say this is 1, so here it is a 50%, here it is a 40%, 30%, here say 60, 70, 90, here 100%, something like that. Yeah, but it is changing very frequently, so we can't see with man normal eye also. Yeah, but it seems like a full wave. Yeah, so what are the things now we have to take care? For example, whatever you are watching here, this is the generation system. In generation system, if all the things are perfectly ideal, then only we will get perfect sinusoidal wave generation. Otherwise there are some problem with the sense. Say we know that, say for example, this is I'm just trying to draw a brief, say this is a DC motor setup. Say this is north pole, this is south pole. Here we have one conductor arrangement. Say this is the conductor, so we have, so whenever this conductor is rotating, the EMF will be induced, right? Because magnetic fields are there. So whatever the magnetic field is there, if magnetic field is uniform, means then the way of producing EMF is different. Say for example, one of the pole is distorted, one of the pole is damaged, then what happens? The EMF is not fully sinusoidally will be induced. For example, say like this. So what happens is it may be distorted. Instead of that, it may be distorted. So whenever even positive cycle and negative cycle both are not replica, when both are not equal, then we will say there are even harmonics. There will be even harmonics. Very so did you think that there will be any problems in the generator? There will be any mismatch in the generator? Very rarely we will have even harmonics in the system. But both poles should be similar, right? There are many different ways also poles to make. For example, this is the magnet. They will, instead of making like rectangular, they will make like a shoe shape, so that we will get closer to sine wave. So they will make like a shoe shape. Yeah, there are different aspects. We will discuss those in another session also. So my intention is, almost most of the magnetic devices are symmetrical. All the alternator generators are symmetrical in the nature with respect to the north and south poles and everything. So almost we will get sinusoidal supply. There will be no even harmonics. That is true. That is true, because positive half cycle, negative half cycle will be similar. 99.99%. Very rarely it will have harmonics in the supply side. So only we have odd harmonics now. What are odd harmonics? How they will be impacting? So odd harmonics with the sense everything. For example, say 1f is the fundamental frequency. So fundamental frequency means say this is the, like the sine wave is there, for example. So what happens? for remaining waveforms. Say if it is a 3f means within this one cycle of fundamental we will have three waveforms. We will have three waveforms here within this cycle. We will have three waveforms completed like that. If it is 5f means the harmonics are different. If it is 7f means the harmonics are different, like that. But the major contribution of harmonics will be third harmonics in the electrical network. Why? Because these third harmonics they are in phase with each other. Their magnitude is going to add in the electrical network. For example, if we draw the waveform, say like this, say this is UVW, one first phase, second phase, third phase, like that. So what happens is, say this is another waveform I am drawing. This is positive sequence. So this is, otherwise this is negative sequence. This is 1, this is 3, this is 2. What happens to zero sequence or like this? They will be all in phase with each other. So this is a three-phase system, like that. This is a third harmonic. All three of components will be, multiple of three components will be in phase with each other, so they won't cancel at any place. For example, here at neutral they are going to add everything. So what happens? Say for example, all are carrying 1 1 1 1, then three times of current will flow in neutral, right? Yeah, that's what the system says. So third harmonics are more complex. We have to take care those. And fifth harmonic, seventh harmonic, something like that we have. And so ninth harmonic, similarly 11th harmonic, and then 15th harmonics, this like this. So now I think you people are clear that only odd harmonics will be there in the system. That too, third harmonic, fifth harmonic, seventh harmonics are very much impacted. Their magnitude we have to take care. Yeah. So we considered 120-degree system. This, why we considered 120-degree system is they are very simple to construct, and constant torque developed across the three-phase system. And if it is a perfectly balanced system, means the neutral current summates to 0, so we can eliminate the neutral, and we can reduce the size of the neutral also sometimes. Yeah, so that's about our 120-degree phase shifted three-phase system and different harmonics. So mostly we will have zero harmonics, zero even harmonics, and little bit of third harmonics in the system. Mostly power supplies, they have one limit for the generation. So say 1 to 2%, like that. Beyond that, the harmonic content won't be there in the power system network. So in the entire network, whatever the, for example, whatever the electricity is board is supplying to us, they are almost, for example, this is the board, so they are almost sinusoidal. But whenever we are connecting any load to that, say for example, this is the load source, this is the load here, so we are connecting a load here. So what happens? Say if it is a resistive load, means the things are very clear. Say instead of resistive load, if you are considering any diode, then what happens? Any diode means this is some non-linear device, right? The characteristics and everything will be different. If it is resistor, means it will be simply like this, so there won't be any issue. But whenever we are considering power electronic devices, their characteristics are different. For example, this is for diode. Similarly, for a thyristor, the waveforms will be like this. So these are not perfect sinusoidals, right? So these are not linear. So whenever even though we are supplying sinusoidal supply, due to the load nature, it will carry a current of different frequencies, multiple of fundamental frequencies. These multiple frequencies we will say as harmonics. Multiple frequencies we will say it as a harmonics. You can see it clearly here, whatever I drawn. Fundamental is green color, so we have third harmonic and seventh harmonic. So the resultant is completely different. Say this is the unit, right? One unit. So due to these harmonic content, here you can see the peak value is completely different. Yeah, here also you can see negative side also the peak value is different. So here but say if like this supply is given to the motor, what happens? Is the smooth rotation will be smooth? No. Here you can see here the rotation is pulsating. These things are not suitable for many industries like paper industry. For example, one motor is running, so it is taking the paper roll. So whenever these type of disturbances are there, that roll will disturb, right? That may break down here. The break may be there. So it is quality problems will be there. So for many industries, supply should be smooth, even though it is carrying harmonic load here, whatever I drawn, even though it is carrying harmonic current load, but still the final output should be smooth. For that, there are various techniques. Those we will discuss in our subsequent sessions also. So these are multiple of fundamental frequency, can either be current or voltage. In power system, these are reasons for frequent cause of power quality problems. Yes, power quality problems will arise due to these harmonics. Now it's just now you can see that there the amplitude is very high due to these harmonic content. So we have to increase our conductor sizes and all our equipment size. We have to increase. Misfiring in variable speed drives. Whatever variable speed drives we will have, the firing also won't occur properly. All the torque will be pulsating torques will be there. So we should take care of these things. Whatever things we will call generally, power means fundamental harmonic power, frequency means fundamental harmonic frequency. Even though we are saying normal 50 Hz system, 60 Hz system, those are simply normal systems, but that value we will call it as fundamental harmonic frequency. 3 MVA, 4 MVA, 7 megawatt, 5 megawatt, whatever the figures we are calling, that is fundamental harmonic power. So what is the problem with this? So with this, whatever extra figure is contributed, say here it may be around 30%, right? Otherwise it may be around 20% here in this case, extra magnitude. So it may cause overfluxing, it may cause overheating, or whatever cooling we consider normal, it may not be sufficient. Yeah, will impact the life of many devices. So these things we have to take care. So how we can take care these things? In up to some extent we can take care these things by considering delta connected transformers and motors. So for example, whenever delta connected system is there, say you are like this, whenever any three third harmonics are there in the system, so say this is, we are giving supply from electricity board. If any third harmonics are there in the system, what happens? They will keep on rotate here. Whatever star connection is there, they won't pass to the star side. So in this way our loads are free from third harmonics. No third harmonics will be there in our loads. Yeah. Similarly, the voltage harmonics also will be there. What are voltage harmonics? 99.99% voltage harmonics will be zero. Why? Because whatever the supply is generating from the alternator, they will be ensured for perfect sinusoidal shape except very rare cases. So voltage harmonics will be almost, we can say, nil. But due to the load, whatever we are connecting in between supply, so say this is the load, this is the source. So whatever the impedance or contribution or devices are there, due to these there is chances of current carrying different harmonics, right? That's what we discussed. NF frequency current it may carry. So due to these current, whatever the voltage is there, that voltage may little bit impact for harmonics. Yeah. So these harmonics mainly the magnetic devices, the capacitors and voltage sensitive devices will be impacted by these harmonics. Yes. So in IEEE we have one standard format of different harmonics. What will be the harmonic profile and all. For example, without going too much detail, what IEEE says is, whatever the say it is, if it is third harmonic, the magnitude of third harmonic can be 1 by third of fundamental. Say similarly, if it is fifth harmonic, the magnitude of fifth harmonic can be 20%. It is seventh harmonic, the magnitude of seventh harmonic can be 14% of so like this it will says. Yeah, these things I will show you in simulated mode also how we are getting these things. Yeah, so these are various loads that are contributing for harmonics. Say, for example, rectifiers. We will discuss more about rectifiers, discharge lighting, and saturated magnetic devices such as motors, transformers, and many things. So there are semi transistors. So transistors here, everything is non-linear. You can observe the characteristics also. IGBTs, MOSFETs, whatever it is there, diodes, all the characteristics are completely non-linear. So there are some common office equipment, computers and printers, fluorescent lighting, battery chargers, variable speed drives, etc. They are all contribute for harmonics. See here one motor is there. If whenever we are simply DC supply is pure DC supply is available means motor will run smoothly. If any we have to convert AC to DC means there will be harmonics again. So the motor performance and everything will impact. So for controlling all the things we have variable speed drives. So that have special precautions. So for example, if it is a 6 pulse, so the circuit will be like this. If it is 12 pulse system, the circuit will be like this. We can go for a number of pulses, say for example 24 pulses, 36 pulses, or 48 pulses, like that. If you keep on increase the pulse number, the whatever the harmonic we are getting, that will harmonic content will reduce. This is why how, because for example say multi-level inverter, say like this, we can get like this, the waveform will be like this. If you are increasing the pulse, let's say this is 3 pulse for example, yeah, so we can take more pulse, right? We can take more pulse. So say if we are taking further increasing the pulse till again, then it is almost closer to sinusoidal waveform. If it is normal square wave means it will be like this. Yeah, it is we can say 3-step wave. This is a single step wave, that is square wave. So like this, by increasing the pulse number, we can reduce the harmonic impact on the electricity supply. Whenever we have electricity supply board, they will impose some restrictions on utilizing the supply. They will ask for you have to comply harmonic content within 2%, otherwise we will penalize you, something like that. So for considering or those for complying those implications, we should take care all our electricity devices and all. So CFL network, CFL lamps also will provide non-linear loads. For example, inside the circuit will be like this. So they will, the only thing is the non-linear will contribute for harmony. Here you can see these are all not sinusoidal. They come when we consider these things, it is a harmonic in nature. So with CFL lamps, so if you are improving power factor, then harmonic content also we can say reduce. If it is perfect resistive load means there will be no harmonics. Yeah, so this is switched mode power supply. Similarly, if you are correcting power factor of switched mode power supply, still we can get benefit. Yeah, these are uninterruptible power supplies, UPS. So all these things will contribute harmonics. Motors generally don't contribute that much significant harmonic generation, but motors and transformers may create harmonics when they are overfluxed or saturated. So the things will be taken care in the design of those motors and transformers, such that the code won't saturate. Yes. So this is about the harmonics. We will go to the simulation to take care of. I am just simulating harmonics now. So y is equal to sin x is a simple normal graph. So now I am just going to add sin of 3x now. So let's see how it will be. So it will be 3 cycles will be there. For example, let's take care of magnitude also. As we already discussed, magnitude will be 1/1/3 of fundamental for the third harmonic. So the waveform will be like this. If you see, say up to here, the things we have one fundamental waveform. Within that, we have three cycles of third harmonic components. Three cycles we have. Similarly, we can see by simply going for. I'm just simulating odd harmonics now. So similarly, fifth harmonic will be there, and it will be 5 times of fundamental frequency. Yeah, so you can see it here. It will be for within first half we have 5 cycles of fifth harmonic. In this way, let's draw for seventh harmonic. So it will be 1/7 of fundamental harmonic. It will be 7 times of fundamental frequency. Yeah, so like this. Simply, let's explore up to generally all harmonics we have to draw actually. So this is ninth harmonic. Similarly, I am going to draw, say this is 11th harmonic. Similarly, I am going to draw, say after 11 we have 13th harmonic. So let's consider 13th harmonic. Similarly, let's consider 15th harmonic. 15th harmonic. So that will be 1 by 15th of magnitude and 15 times frequency. So similarly, let's consider 17th harmonic. So it will be 1 by 17th magnitude and 17 times fundamental frequency. Similarly, let's consider 19th harmonic. It will be 1 by 19th times and 19 times fundamental frequency. Now let's consider 21st harmonic. So it will have 1 by 21th magnitude. Similarly, yeah, so this is the final harmonic. Up to 25th harmonic generally people will consider, because up to that the magnitude is impacted. After that we can ignore the effect of other harmonics, because they will have very less. I think he didn't shown to us. I am not sure whether it will be okay. Yeah, no. Yeah, we are able to see up to these harmonics now here auto plotted. So I'm just going to draw up to this harmonics. I think we already copied it, right? So I will paste it here. We can use it later. So let's summate everything now. So I will keep a plus symbol for everything. Yeah, so this is, guys, up to 7th harmonic we are going to plot now. So it's still not coming, so I'm going to eliminate one. Yeah, so the result will be like this. You can see it, right? Yeah, the magnitude is a little bit different. The waveform is like this. Let's take green waveform. See here, it's almost matching, but the effective value, the RMS value, whatever will be there, it will be more when compared to normal case here, because RMS value is nothing but the area under this graph. You can see with by including harmonic, the area under the graph is too much high, so it will have adverse impacts on heating and all. So how to reduce all these things, harmonics and all, we are going to see in our next videos. I also clearly explain why these harmonics are coming and all. Thank you friends, thanks for watching. Please subscribe to this channel for many more updates. Thank you, bye. We'll meet in next video.